In this section of my testing video, I will be talking about the different web pages and the tests related to StockSense, my web app, before you log in. So this page is the solutions page, where it basically includes all of the different things that the web app as a whole does, including optimizing a portfolio, providing market insights, and to provide stock predictions, which is the most crucial bit of the entire Coursework project. Then moving on to the community hub, these are all clickable links, and it basically firstly offers a welcome to the community. And if I were to click the second link, it just jumps to the, well, for example, in this case, the discussion subheading, and this page as a whole just talks about the different features that I have and the community that we at StockSense create. And then moving on to the next web page is the resources web page, which basically describes all of the things that we offer here at StockSense, including a discussion forum through the comment section in each individual company stock web page, which I will be getting onto later, and the market insights of different companies and different stocks that we predict here, and as well, again, linking back to the comments section. And then moving on to the Contact Us webpage. For privacy purposes, these are all fake addresses, phone numbers, and email addresses. And in the contact form, you can fill in your name. Example, I will do, my name is Harry, and my email for this purpose. There are no email checks at the moment, so that'll be Brain, an example email address, and an example message. And as you submit this, it reloads the entire web page again as detailed here, which I will get onto in a different section. And the email should have been sent as I reload my mailbox, and I should have gotten it here. Following on from that first section, after the page reloads, as detailed as I mentioned before, the entire backend runs again, and then after that it should bring you back to the home page. And now, for example, if I were to go back to the contact web page and not fill in all of the things, so I'll do Harry again, I'll leave that blank because you have to fill out some of these fields. And then as I type in a message, like, hi, my name is Harry, for example, there is a message returned saying please fill out this field. So now I fill this back in again, I submit it, and now I have the entire thing reloading again, the entire back end executing again as detailed here, and it should still take us back to the home page. And for speed purposes, I will not be showing that. In this section of my testing video, I will be talking about the sign in and the sign up mechanism and registering an account with StockSense. So back here is the base URL, which is the home page, and as you click register, it takes you to the sign up page where you can fill in your username, password, and re-enter your password again. And another fun functionality is if you click the logo again, and then again takes you back to the home page, which might take a while to load. So now that we have returned back to the web page, we will click onto the register button, which will redirect us to the register web page. And now once we're back here, as I said before, we've got the username, password, and confirm password. And as you can see, there's a problem that tells us to please fill out all of these fields. So I'll be making, for example, a random username without filling in the other two boxes, which when I register will prompt me to fill out this field. And this is me filling in a password which basically does not meet any of the password requirements for complexity. And I'll also skip this one out. Again, it says please fill out this field. I'll submit it again without meeting those password complexity requirements, which says, again, prompts out a message saying password must be at least 8 characters long, contains at least 1 uppercase letter, 1 number, and 1 special character. And this and also says the passwords do not match, which is an error that also pops up. So now if I fill in a password that meets these requirements, and when I register, this will redirect us to log in. So if I now were to log in, I'll leave the password thing, I'll leave the password label input box blank. It will tell me to please fill out this field. Now I will actually leave the username box blank. It prompts me to fill out the field. Now I actually fill everything out correctly, and it will allow me to sign in. In the case where, for example, I entered the wrong password, for example, now that I'm back at login, I just logged out. So then if I were to do the wrong password, completely wrong password, sign in, it'll basically in my console say password verification failed, which and also it just will never ever let you get past the login page and clears all of the input fields out if you fill in your password wrong. So now that I fill it back in correctly, sign in, then when you reach this web page, you know that you've definitely logged in successfully. So in the case where a user does accidentally forget the password, there's always an option to change your password. So if the user does have an account with us, you can always click onto the login page and then you'll click on forget password. This will redirect you to the forgot password page where, for example, if you enter an email, the completely wrong email, not on the right format, then click submit. It will say please include in that and the email address because it's just not in the right format. So if I now enter a wrong email, a completely wrong email, I click submit, even though my console will say an email has been sent to that email, when I actually will go to the email that is being sent from, it should return me an error saying the address was not found. So now if I actually go back to my web page and I enter a valid email address, I click submit, and now I should have received this, a password reset from StockSense. I click on the link to reset the password, click my username. For example, this goes through the exact same logic as when you sign up with us. If, for example, I fill in a new password, leave confirm password empty, it should say please fill out this field, and vice versa. If I don't fill out one of the other fields, please fill out this field. Now if I fill in a password that does not match, you can obviously see that it's 2 different lengths of passwords, so obviously it doesn't match. So passwords do not match. And those passwords also did not match the password complexity. If I do the exact same password with the wrong complexity, like just it's not complex enough, that error returns again. Now if I actually enter a password that is complex enough, then submit, and it should redirect me to the login page. And once I log in, fill everything in with the right username, right password, sign in, it should redirect us to the home page. In this section of my testing video, I am going to go over the fact that a password reset link cannot be accessed past an hour of when that link was requested. So as you can see with the first email in my inbox, the email was sent on the 18th of March, which was well over an hour away from today, which is the 25th of March. If you click on that and click on the link, it should directly redirect us to the forgot password page and flash a message because you were not allowed to. The password reset link is invalid or has expired. So in this section of my video, I will be talking about mainly the dashboard page of my web app, StockSense. So to begin with, I would just like to talk about the news display container, which is this. It displays 5 of the top headlines in the technology sector right now, which is fetched by News API. And it displays the outlet, the headline, and the details of that headline. And as you can see, this is somewhat interactive. And when you click onto the link, for example, on this one by gizmodo.com, it redirects you to the link where the article was posted, just in case the user would want to fully read the entire article, just get a glimpse of it. So on this is, the links are actually interactive for every single web page. So if I, for example, go to Pokemon Go Hub, it'll redirect me to Pokemon Go Hub. And then scrolling down, moving on, there's also the details bit, which summarizes the news headlines of each of those headlines. And then here with the countdown to close, I'm currently filming this at 5:45 Greenwich Mean Time here in London. And the countdown to close, which is in 2 hours and 14 minutes, which means the stock market, the New York Stock Exchange should be closing at 8 p.m. Greenwich Mean Time, which should be 4 p.m. over there in New York. And moving on to my left, this bar is in fact collapsible. It contains all of the different links that the user could navigate to and could access post login. So the dashboard is obviously dashboard, user profile, which I'll be talking about later, but you navigate to user profile, there's user profile, then Apple, which goes to Apple with the predicted price, and Google, then the S&P 500, S&P 500 IT sector, the Nvidia stock, the Microsoft stock, the Tesla stock, the Nasdaq stock, and the Intel stock. I'll be going more in depth into these different web pages in another section of this video. In this section of my testing video, I will be trying to access pages that are protected by the login required function as demonstrated here, which I should not be able to access without being logged in. So as you can see, I have just restarted the Flash server, which means that there are no session cookies, basically meaning that no user is currently logged into the web app. So if I go and access this page over here, I'll just go back to the home page and I try and access. Keep in mind there is just, like right now there are no session cookies, so Flash does not know that I am an actual user. It will redirect me to the login page. This is what should be returned upon me trying to access every single individual page. So the page I just tried to access is the dashboard page, which should be accessed straight after the login. So now I am going to try to access the stock page, that is the company specific stock page. For example, I'll just do a random stock ID. This should take me to the Apple page. Again, redirects me to the login page. Let me start back from scratch so everything is clearer. The last page I will be testing is the user profile page. And again, it should be redirected. It should redirect me to login. Again, the pages that the URLs that I just tested are of those that correspond to actual web pages. Some API fetches are also login required protected, so it is also protected by a login decorator, but for the purposes of the front end, I will only be demonstrating those that have an actual page, such as the ones I just demonstrated, which included the dashboard page, post login, the company specific stock page, and the user profile page. So in this section of my testing video, I will be talking and running you through the tests for the user profile page of my web app StockSense. So this is the user profile page, and you can navigate to this page with the user profile button. So if I, for example, go back to dashboard and then go back to user profile, here's the user profile. So first of all, you obviously have a username displayed, and because I am using a dummy account called practice at the moment, this will be the username with the color theme of 0, which will be an aspirational objective that I'll be implementing, that I plan on implementing in the future, the date of creation of which the account was created, and the user ID for the purpose of the comments in the company specific stock web pages. So I currently already have a pre-existing portfolio called tech. So, but however, if I were to create a new portfolio called like first portfolio, I can create that portfolio. It'll be shown down there, and I can select whatever portfolio I want, and then I can add a stock to that portfolio. Let this be Apple, for example, and add the stock. The stock was the first portfolio. Same with tech. I wanted to add Apple as well. I can add that there. Yeah. Also, if I did want it to remove a stock from that specific portfolio, I could always click delete, and then the web app then sends a warning saying, are you sure you want to remove this stock? If you do, click OK. If you don't, click cancel. Then OK, and then it has been removed. So there is also obviously the option to delete the portfolio itself. Obviously, that will be delete. Are you sure you want to delete this portfolio? Because obviously it's deleting, it's a big thing. So I click OK, it's delete. Same with this. If I do want to delete this, I can click OK, and then no portfolio to be loaded, and it will show up a message saying no, like you have no portfolios yet. And this change is reflected here. For example, so it first initially fetches the portfolio tech after I created the tech, after I created the first portfolio, then obviously reloads, the post is run from my Flasks app.py, and obviously that this is dynamically fetched from my database, and is obviously put into the website, the web page. And obviously, since I had no stocks in that portfolio at that given time, so now it just loads that. And then once I added the stock, Apple, as you can see, and then Apple, and once I delete it, now only first portfolio is present because I deleted tech previously. And then now obviously I deleted both portfolios, so there are no portfolios loaded, and there are no portfolios, with the stocks and everything loaded onto the website. So in this section of my testing video, I will be talking about the company specific stock web page. So the exact same tests apply to each individual test web page, and for the purposes of keeping this video sensibly long and of a sensible time, I will be obviously choosing a random stock and just testing the website itself. I'll try my best to implement all of the tests with every single stock web page, but obviously that isn't exactly that feasible. But either way, as you can see in my code, there is one stock page HTML that applies and is inherited for every single specific stock web page, where the stock ID, like the respective stock ID and all of its information along with it, is passed on to basically parse and generate the HTML for that specific stock web page. So then, as you can see here, it'll be like return render template, this HTML file, the stock ID, stock symbol, company name, which therefore means that I could have one single HTML file which applies for every single stock in my website. Anyways, moving on, there is the, for example, I would just use the S&P 500, which is the index, one of the indexes on the New York Stock Exchange. So the first test would be basically obviously just to see whether the visualization exists as a whole, which it does, because you can obviously see it right here, and you can see that. And so the blue line here demonstrates the actual price, with the price on the y-axis and the date on the x-axis, and these are the dates over the past 4 months, as you can see. and then you can basically, when you hover over it, you can see, sorry, not the past 4 months, or from the beginning of when my stock actually starts. You can see that it's like February, January, whatever. When you hover over it, you can see the date, the time, the actual price, and you can see its progression as a whole up until here, where you have the actual price, different price points, because on this day I actually regenerated I loaded the back end twice, hence why there are 2 different prices, because Y Finance continuously updates its database. And obviously on this day I ran my data update file, which meant that there are obviously a lot more prices here, which is a discrepancy I will have to resolve in the future. And then once you get to the predicted price, this is the price that this stock forecasts for that specific date. So it does exist and it is interactive. And now that if we scroll down here, you can see the current market price, which is the last actual price present that's recorded by Y Finance, and the projected future price, which has been calculated through a 20-day weighted moving average. So throughout the entire prediction period, for the last 20 days, it will basically take each price and calculate a weighted moving average from that, and the result of that calculation is displayed here. And depending on which value is greater, and in this case it will be the projected future price, the StockSense, the software, will basically recommend you to buy the stock. And so I just spoke about the potential earnings, and moving on, I could basically, the whole comment functionality, because I don't have a comment on this page yet, I could enter a comment. For example, this is a great chance to buy this stock, and then I post it. And because my user ID, there's the user ID displayed as well as a date that has been posted in the format of month, day, year. The option to like or dislike, and when I do want to reply to comment with comment ID 7, which is this, I can just say, for example, yes, I agree. Post, it'll be indented, and yet again you'll see a like dislike button. So an example of how this also has been displayed is with the Nvidia stock, where I already have pre-existing comments. As of now, there's no option to unlike a comment you've already disliked. So whenever I like or dislike a comment, that number will just keep on increasing depending on the number of times I click the like or dislike button. The amount of times I like and dislike, this number is also added onto the database related to that comment, that database entry. So even when I reload this page, those existing comments will still be there because it continuously just fetches from the database. In this section of my testing video, I'll basically be talking you through how the back end of my code works and with the test cases for my back end processes. So upon accessing the homepage, because I previously logged out, hence you can see the logout call here. I've logged out from user profile, and when logged out, you're automatically redirected back to the homepage, and I have decided to put the data update.py execution call inside when calling my homepage, because I thought it was most sensible given the fact that it should be one of the least accessed pages out of my entire software, whilst remaining a compulsory access point in comparison to other less frequently access pages like the contact page or the solutions page, where you don't necessarily have to navigate to that page in order to log into the software. So hence why I put it in the home page. So I logged out, I accessed the home page. While the home page is loading the main program, which is the function call, which I place the other 2 function calls within, which is all demonstrated in my technical solution, this runs. So first of all, this whole yf.download function, you may look at it and just think, why is this happening? So first of all, the program will generate predictions. CSV will first establish a connection with MariaDB, which is where my database is and what it is. So when we're fetching stock data for those specific dates, because obviously Apple failed to download, as you can see, because, well, throughout that 1 day period, there could be a chance where Yahoo Finance just simply wasn't updated for that day. but usually it does work. Usually the data does update as seen from this page. Let me just quickly navigate to it. But while I am speaking on the matter, my stock app does include exception handling for cases like this where, for example, the JSON decode error, which I have run into multiple times. So an example would be this webpage, well, not this webpage, sorry, the database schema, where obviously there are dates, entries of stock data up until March 18th, possibly due to the fact because when you do try to fetch March 19th, which is a day previous from the day I'm recording this, perhaps Yahoo Financial simply hasn't updated data onto its API for us to fetch. So also why there was a failed download for that specific price, and that basically applies for all the stocks. But this does not stop the whole main program from executing, which is the important bit of this entire software and the entire workflow and functionality. So moving on to this section, this is where the macroeconomic data fetch does happen. So GDP-C1 represents the real GDP of the US, and here I've printed out the 5 latest quarterly entries of real GDP in the US. And after that, unrate is the unemployment rate in the US, and again, those are the last 5 entries, quarterly entries of the unemployment rate in the US. Following that is CPIA US, UCSL, which is the inflation rate in the US. Well, NAN, not a number. What if there was just not an entry something for that day? So obviously the code will handle it. Again, does not stop the whole program from not executing. And again, displays the last 5 entries. And then after that, it's the consumption in the US. Hence the last 5 entries of that as well. And then following that, this just displays, well, I run the .describe function just to get an overview of my data, how many entries there are, the mean, the standard deviation, the minimum, the different quartiles, and the maximum, just so I ensure that there are no discrepancies in anything. And then moving on, this basically updates that log return, which is the thing I'm predicting, the log return in between each day with each entry of the closing price, so that I don't experience any predictions explosions, which is what I have been experiencing previously. So hence why the log returns are currently predicted. I went through a stage where I initially predicted the closing price, and now I'm moving on, and then I tried to predict the percentage change. Obviously still meant that the predictions exploded, which is exponentially increasing to a large amount or exponentially decaying to a really low price. So hence now log returns are being predicted. It prints out the index of where it's displayed in the data frame. The columns of the scaled data frame, which is a normalized number between 0 and 1 of each of the different columns. Each column, each data entry is normalized, and those the indexes in the scaled data frame, along with different feature columns as well, because that's very important. And the features are also scaled by the min-max scaler. And then when pre-processing my code, I have also inserted assertion checks for chronological data, because that is very important, and I've also included that in my technical solution as well, the whole walkthrough. And then it obviously prints the shape of X, shape of Y, and then after that you've got the sizes of the training set and the testing set to ensure that a fair 80-20 split has been done. And because when I built my hyperparameter search testing LSTM bidirectional LSTM model, I wanted it to be stateful so that I could reset the states in between, because the one thing I didn't do initially was I didn't implement the resetting of states, which could only be accomplished with a stateful bidirectional LSTM model. So I had to retrain my entire model, rebuild it, redo the whole hyperparameter search, so hence I could reset the states so that again the predictions won't explode. So because of this, there has to be equal and complete batches, so hence we drop the first so and so number of samples. In this case it's 28 and 9 for training and testing respectively, to form complete batches, because you have to have that. It's a requirement for a stateful LSTM model. And because I have ran this hyperparameter search previously, so it recognizes that I have and has found it in my project directory, which is displayed here. It recognizes that I have run this, or loads the pre-existing model, displays the parameters, the layers, the output shape, and then just kind of trains the model on the most up-to-date data. And now is where we start predicting everything. So there's obviously the test loss displayed there, different stock IDs displayed there, and then most of this is just predictions. So I'll just walk you through an example. So log return scale, this obviously truncates and rounds up to 0. And you've got the center value of the scalar and the whole range itself. And then you still have that going on and on and on. It's just this is just to measure the deviance between the log returns to ensure that my predictions weren't exploding. Because what happened initially is that this value came up to about 3 point something, which essentially meant that it just kept on increasing. Or, well, my center went down to, I think there was a time where it went down to -5. Which then again also meant that my predictions ended up exponentially decaying. So now that that is fixed, most of it is just, well, different entries, just for debugging purposes simply. And then after that, basically the first couple, I think this was the first 20 entries, I forgot what I wrote in that code, should be just about of the earliest predicted prices that I have for the earliest stock, which in this case is stock 43. And obviously the evaluation metrics are stored in evaluation metrics.txt, which is the text file, which is here. So you've got the average trading loss, the best trial ID, which is 22, the extremely negative log returns. This has significantly improved. I now clipped it at, I think, -10 and 10. And then the mean absolute error, the mean squared error, and the R squared score, which is arguably the most important evaluation metric there is, in my personal opinion. And then obviously MAE and MSE comes second after that. And obviously with a time series stock forecasting context situation like this, it's obviously best to have an R squared score above 0.7, and this is 0.78, which is a very good sign. And the combined CSV of all of the predictions I have for my web app will be displayed here like this. Basically, it just, the whole thing, let me scroll back to the top, goes by date, stock ID, actual price, predicted price. So for example, with the very first entries with stocks D, well, in my data frame, the very first entries are from the 2023 January 1st or January 9th. So I thought it was sometime January. So you have the actual price displayed, because at that point I haven't started predicting yet. So when there is no predicted price available, only the actual price is displayed. And as you'd think, vice versa as well, when there is no actual price and the predictions do actually start, the actual price isn't displayed inside the CSV, but it is displayed as part of the predictions. And all the predictions basically only shows a general trend of how the price will go or tend to.